Hello everyone, welcome back to my channel. I hope everyone is doing great. My name is Ravi Teja. Let's solve today's Leetcode problem 1680 concatenation of consecutive binary numbers. Given an integer n, return the decimal value of the binary string formed by concatenating the binary representations of 1 to n in order modulo by 10 power 9 plus 7. Okay, if you take n is equal to 1, there is only one number which, okay, so its binary representation is 1 and the corresponding decimal value is also 1. If n is equal to 2, so we have to concatenate the binary representation of 1 and 2. Okay, so 1's binary representation is 1, 2's binary representation is 1 and 0. After concatenating these two, you will get 1 1 0, right? If its decimal value is basically 6. Okay, so how can we derive over here? One thing is to go ahead and concatenate and then get the number, right? Or you can simply do, you can write this number as 1 0 0 followed by 1 0, where we are actually left shifting the current number by the number of bits in the 2 has 2 bits, right? 1 0, so we'll be left shifting our 1 by 2 bits, which will give us 1 0 0, and then we'll do OR with the 2. This will give us 6, right? That is what I have written here. We are doing 1 left shifting by 2 and then doing OR with 2. Okay, again, if let's say n is equal to 3, okay, if n is equal to 3, that means you have to concatenate 1 2 and 3. So 3 has already, we have formed the number till 2. Now we should also concatenate 3 to the result, right? So when we are concatenating 3 to the result, that means again the number of bits we have in 3, those many bits we have to left shift, right? So this, if you see 1 1 0 is 2 and double 1, right? So it is nothing but 1 0 0, which is the answer coming from here, and then left shifting by the number of bits we have in 3, and then we have to do OR, right? So at any given point, all we need to do is identify the number of bits the current number has, and then left shift the previous result so far we have by those many bits and do OR with the current number, right? Do OR with the current number. Okay, so that is one approach. So which will take, basically, since we will be looping from 1 to n, right? 1 to n, it will be n times log n, where log n is basically identifying the bits in the current position and identifying the bits of the current number, right? So we can actually do better over here. Okay, if you see, 0 has 0 bits, 1 is basically 2 power 0, which has 1 bit in it. 2 is actually 2 power 1, which is 1 0, which is 2. Okay, 3 is basically 1 1 in its binary representation, and the number of bits we have is basically 2. 4 is basically 1 0 0, and we have 3 bits, right? If you notice, if we do bitwise AND of these two numbers, this will turn out to be 0. Okay, even if you notice for 2, it will turn out to be 0. That means for any 2's power, if you do the bitwise AND with its previous number, you will always get 0. Okay, if n is a power of 2 and n minus 1 will, if you do bitwise AND with n minus 1 and n, you will get 0. The reason being, if you left shift n minus 1 by 1 position, then only you will get this number, right? So if n is a power of even, n is a power of 2, then n minus 1 will have all bits set, but with 1 bit lesser than this one, right? If you see, it has 2 bits and it has 3 bits, right? And all the bits here were set, and here only 1 bit is set. Okay, so whenever we are encountering an even number, whenever we are whenever we are encountering a power of 2, the number of bits will increase by 1. Okay, so if you see, so far we have 0 bits. Okay, in 0, 1 is basically a power of 2, so the number of bits will increase by 1, which has become 1. Now for 2 is also a power of 2, so again the number of bits will increase by 1. it will remain constant till we reach another power of 2. Okay, so for 3 it will be remaining same. Now 4 is a power of 2, now the number of bits will increase by 2. Okay, so what we will do, our even we also want the number of bits, right? If you simply keep track of a variable which will, let's say digits is a variable which will keep track of the number of bits so far we have. Okay, and if the current number is an even number, if a current number is a power of 2, then we'll simply increment it by 1. Okay, that will give the final number of bits for a given number. Okay, so I will start from 1 and go all the way up to the end, and if the current number is a power of 2, then I will increment the number of digits by 1, and then what I will be doing is we have to concatenate the previous number and the current number. So nums will be the so far answer. Now what we have to do, we have to shift the nums by the number of digits currently we have, and then we have to also add the current number to it, right? So we will be left shifting it by the number of digits, but instead of directly adding the number, we will also take the modulo. Okay, because the number can be very huge, so we will simply taking the modulo for the left shifting, and after adding also we'll take the modulo, so that the overall result will lie within the range of 10 power 7, 10 power 9 plus 7. Okay, in the end, after all these iterations, our final number will be the answer. Okay, if you submit this, all the test cases will be passed, and it is pretty efficient solution as well. Okay, as you can see, we are just using two variables. Okay, nothing more than that. The space complexity is big of 1, and the time complexity is, we are iterating from 1 till n, right? So the time complexity is big of n. The previous approach where I have mentioned, instead of this, we will be recomputing the number of set bits again and again, which will be of log n. So the initial approach will be taking n log n. So int so what I was telling is, int digits is equal to, since I is int, right, it will have maximum 32 bits, and integer dot number of leading zeros of I. This will give you the total number of bits set, total number of bits in I, right? So if you run this problem, you can see all the test cases were also passed, but here this will take a time complexity of log n, because we are identifying the number of bits explicitly. So this will be log n, and the outer loop is n, running for n times, so the total time complexity will be n log n if you go with this approach. Instead of this, if you go with this approach, where since we are going from 1 to n, and at any given point we know what was the number of bits we have previously, and if we encounter an even number, we'll simply increment the bits by 1. Okay, so this, using this approach, your time complexity will be reduced down to big O of n. Okay, if you like the explanation, hit the like button and hit the subscribe button. Share your valuable feedback in the comment section. I will be posting the solution in multiple languages such as Java, JavaScript, Python. Feel free to check it out. And I have also started Leetcode study plan for dynamic programming. Okay, feel free to check it out. Okay, I've already solved, I posted the videos from, I've solved 19 problems, and I've posted the solution for all these problems on my YouTube channel. Feel free to check that playlist as well. I will be attaching the link in the description. Feel free to check it out. Thank you.